Okay, right, we can start. So today we are going to discuss about the chemical bonding part. I hope you can hear me, right? If you are having any trouble, you can use the chat box since I'm using a mic. Okay. So if you are having any trouble related to this study material, or if you are getting any sort of questions or something like that, so you can use the chat box. Those who are joining from Zoom can use that chat box, and those who are joining from the live stream also can use the chat. Okay, so I will be using both uh, two platforms to conduct this session. So from today onwards, so all the sessions will be broadcasted like this, and also remember, these sessions will be available until you face the exam. So uh, with the time you can use these modules actually, right? You can use these tutorials, these videos until you face the exam. So there are few more days for the exam, so please work hard, right? Okay, so we'll start. So today we are going to discuss about the chemical bonding part, and so as you know, when it comes to chemical bonding, uh, so in your syllabus there's only like three special bonding types, right? But once you are studying for A level chemistry or something like that, then you are having different sort of bonding patterns. So here in your O levels, we will be discussing about uh, the few primary bonding types, right? Those who are in the chat box, those who are using the Zoom, all right. So please tell me whether like, can you guys clearly hear me? And those who are joining using YouTube also can use the chat box, okay? Right. So just give me a minute. I need to share another screen. Right. So now, yeah, I will be using the whiteboard. Okay. Right. So, if there are any sort of issues, please drop a message, then I can try to sort it out. Right. So when it comes to chemical bonding, so I will use the main categorization of this chemical bonding thing. So when it comes to chemical bonding, we can divide them into primary bonds and into secondary bonds. So primary bonds means you have a direct involvement of electrons. You have direct involvement of electrons when it comes to bonding. Secondary means you have, like, you don't have this direct involvement. So that is the main part that you need to remember, right? Direct involvement, but here there will be attractions, mainly attractions between electrons. So that is the difference, right? Attraction. So I'm simply explaining these things stuff, right? So you are having direct involvement versus the attractions between electrons. So when it comes to the primary bonding, when it comes to the primary bonding, what happened? All right. When it comes to the primary bonding, so this primary bonding thing can be divided into subcategories again. So here you are having covalent bonds, ionic bonds, and finally the main one, metallic bonds. And when it comes to attractions between electrons, there are so many types of them, like dipole-dipole interactions, like those things. But for your syllabus, the O-level syllabus, we don't discuss about those stuff, right? And you might have heard hydrogen bonding as well. So hydrogen bonding and the other attraction forces. So please do remember that these stuff won't be tested in your IGCSEs, right? It won't be tested in your IGCSEs. Only the primary bonding thing will be tested. Okay. Then, so since we are preparing some, like, some short note material, so therefore, like, we are not going to deep theory discussions, but I'm just memorizing all the needful stuff, right? So here we need to uh, pay attention to these covalent bonds, ionic bonds, and metallic bonding thing. So here we'll prepare a table. So I think it's better for you guys also to write down this. No need of writing this secondary bonding part. So therefore I will cover it, right? So there's no need of writing this stuff. The primary bonding, write down the categorization, right? Write down the categorization, then we'll prepare a table where you can see the differences or the comparison between these three bonding types. Right. So we'll prepare the table. So here we are having the covalent bonding. Then we'll discuss about ionic bonding then. Ionic bonding, then the metallic bonding. Right. So first of all, remember, it's better to memorize these theory parts, memorize these structures or the bonding patterns using a diagram, right? So my advice is to, like, when it comes to any sort of studying purposes, let's say like you are studying biology or something like that, let's say a system, a digestive system. So first of all, try to prepare, like, try to draw the whole digestive system and try to memorize the parts there. Likewise, you can use these diagrams to memorize whole theory parts when it comes to studying purposes, right? So remember, in covalent bonding, what will happen is that you are having a nucleus, another nucleus. So the electrons, so I'll draw something like this. So this is the energy level of the first atom, and we'll say this is the energy level of the second atom. So the electrons will be here, right? So I have used these arrows in two different directions. No need of knowing why I have used these arrows. So all the explanations are falling into A-level chemistry. So here I'm not going to touch A-level chemistry since you are just O-level students. Okay. So you can draw the covalent structure like this, right? Or we'll draw, instead of arrows, we'll draw dots, right? Dot or a cross. So dots and the cross, right? And the main term that you need to remember, right? The main term that you need to remember is the electrons are being shared here. Okay. The electrons are being shared with each other. So electrons are shared among the two atoms. That is the main sentence that you need to remember. Electrons are being shared. So in what purpose the electrons are being shared? Why do we need to share the electrons? So the reason is in order to fulfill their energy level. To fulfill their energy level. So fulfill means you need to fill the energy level. So from here you can remember the electron configuration, how to write the number of electrons. So 2, 8, 8 is the accepted way that we are using. So this represents the first shell. This is for the second shell. And this is for the third energy level, right? So these are the maximum numbers. So in order to get the maximum numbers, we are sharing electrons with each other, right? Then the ionic bonding. So main thing is that we are dealing with ions here, right? We are dealing with ions. So the main ions that we have, right? There are two types. We have the positive ions and we have the negative ions. Positive and the negative ions. So last time, as I can remember, we discussed how the ions are being made, right? So you can make these ions, you can form these ions by removing electrons or by gaining electrons. So the positive ions are being made by removing electrons, and the negative are by gaining electrons, right? Are by gaining electrons. And here the diagram that you need to remember is going to be something like this. So you are now dealing with the positive ion, right? We'll draw something like this, right? So this is the nucleus. And here you are having the positive ion. And this one is going to be the negative ion. And there's going to be, so here we are dealing with positive and negative ions. A strong attraction force will be there, right? So this thing is the strong attraction force. In some textbooks, it says electrostatic, right? Strong electrostatic attraction force. We'll write down the same thing, right? Strong electrostatic attraction force. Strong electrostatic attraction force. So remember, we are dealing with ions there, right? We are dealing with ions there. In most of the cases, so for, let's say, we'll discuss some examples as well, right? So here you will have most of the inorganic molecules, something like hydrogen and We can have chlorine, oxygen, likewise. And here the ionic ones, sodium chloride, magnesium chloride, right? Likewise, you have different sort of ionic molecules. Then the metallic bonding. So the main diagram that you remember is something like this. So here we are having a term called the electron pool. Electron pool. So electron pool means, so when it comes to metals, the nuclei, right? They are arranged in a pattern like this. The reason is like most of the metals are solid. So therefore, like solid particles, they are having this specific arrangement, right? And these electrons will be like this, right? And these electrons can be like, they can be moved if we apply a potential like certain ends like positive end or a negative end. Just imagine we are connecting it to a battery, right? We are applying a potential. So these electrons can move. So therefore, we name these electrons as the delocalized electrons. Delocalized electrons, which means they can be moved, right? They can be moved under certain conditions, right? So these are the three diagrams that you need to remember. So this is the first one, covalent. The electrons are being shared. And the second one, ionic bonding, you are dealing with electrostatic, strong electrostatic attraction forces between the two ions. And when it comes to metallic bonding, this is the diagram that you need to remember, right? This is the diagram that you need to remember. And another important point is that the strength of a metallic bond, it will depend on, right? It will depend on the size of the nucleus or the size of the atom that we are dealing with. And the second factor is the number of electrons that is contributed into the pool, right? The number of electrons that are given to the bond. So if we consider an example here, let's say we are comparing with the sodium metallic bond with magnesium metallic bond, right? So magnesium provides more electrons and the size reduces. So therefore, magnesium will be having a higher strength, right? Magnesium will be having a higher strength. So remember, size of the nucleus must decrease and the number of electrons must increase, right? The number of electrons must increase and the size of the nucleus must decrease. So that is the main theory part behind this explanation, right? So if you consider the position of sodium and magnesium in the periodic table, so magnesium is a small atom compared to sodium, right? And the number of electrons that will be given into the system will be higher than sodium. So depending on those factors, magnesium metallic bond will be more strengthier than the sodium metallic bond. Okay, right. So I'll give you a few more minutes. We'll copy this down. Okay. And once after you have finished, just give me a reaction. Just put a thumbs up. Then I'll move on to the next one. Okay. Right. Then we'll move on to the next thing that we need to discuss is that mainly the properties of how to uh, yeah, we'll discuss about the properties here. Then yeah, afterwards we'll discuss. No, first we'll discuss how to yeah, right. Okay. So the first subtopic is going to be the covalent bonding, right? So if we consider the covalent bonding, as we mentioned, the electrons are shared among the atoms, or you can say the nuclei, right? Atoms are atoms of the nuclei, right? So let's say something like this, right? Uh, I'll use an example and yeah, right. So we'll say the first example, I'm going to use the hydrogen molecule, right? So in the exam, they will ask you to draw the structures of these molecules. Structures means like how the bonding occurs, right? So you can use these steps, right? So the first step is that, mm, first of all, identify the atoms that you have to deal with, right? So here there are two hydrogen atoms. So I'll write the two hydrogen atoms like this, right? The next step is you need to write the correct electron configuration. So hydrogen, each one is having one electron, right? Each one is having one electron. So therefore, the configuration is just one, right? Just one. Now, we need to consider about these three numbers, the order of these three numbers, right? So the first level, in order to complete the first level, there must be 2 electrons. But here, in these specific atoms, you are having just 1 electron, right? You are having just 1 electron. So it means it requires another electron in order to get the level up to 2. And this one also, it requires 1 electron to upgrade the level up to 2, right? So what will happen if these two are to be shared, right? If these two are to be shared, then both these hydrogen species will be happy, right? So therefore, what will happen is one hydrogen atom having 1 electron and the other hydrogen atom having another electron. So if we share them, you will be getting a diagram like this, right? So these 2 electrons, actually, this one belongs to this one, and this belongs to this hydrogen atom. So if we draw a diagram like this, then what will happen? These 2 electrons are belonging to this hydrogen atom as well as this hydrogen atom, right? So now both has the configuration of 2, making both happy, right? So, and another thing, uh, so when it comes to these covalent bonds, remember if just 1 electron pair is being shared, right? Just 1 electron pair is being shared, then it will be known as a single bond, right? It will be known as a single covalent bond, a single bond. So in order to display these single bonds, we are using just a dash, right? So normally remember these shared electrons, right? A shared electrons, right? A couple, a pair of shared electrons will be mentioned using a line, right? So therefore, this hydrogen molecule can be written like this, right? It can be written like this. And if we consider another example, let's say the oxygen molecule. So here, again, we are dealing with the same atoms, oxygen having 8 electrons each. So if we write the configuration, so these are the most important steps, right? So it will be, so the first level can occupy maximum of 2, and the second level can occupy maximum of 4, right? Sorry, maximum of 8. So therefore, it will be, if we write 2, 8, then it is wrong. It will be 2, 6, right? So the reason is like you need to have total of 8 electrons. So the first level will be getting 2 electrons and the remaining 6 will be in the second electron level. And here also you are getting the same condition. And the main thing that you need to remember here is that, so this represents the first electron level, and this represents the second electron level. So which means this second electron level is the outermost level, right? So that is the outer shell, outermost electron shell, right? So let's say something like this, right? So this is the nucleus, and this level will occupy 2 electrons, and the second level, so it will occupy 6 electrons. So that is the outermost level, and there's a special name given for that. That is the valence electron shell, or the valence electron level, valence level. So the electrons in the valence shell, those are known as valence electrons, right? Those are known as valence electrons. So the electrons in the outer shell, they are known as the valence electrons, right? So if we draw the electron arrangement in these molecules, so let's say oxygen nucleus is something like this, and the second level you are having 2 electrons, and here you are having 6 electrons. So it's better to draw them in couples, right? So 1, 2, 3, and 4, and 6. So the next molecule will be same as this thing, right? I'll use a different color. So this is the nucleus. And the first level, you are having 2 electrons. And the second level, you are having 6 electrons. 1, 2, 3, and 4. 5 and 6. Right. Now, with the configuration, so the configuration is 2, 6. So the level must be upgraded to 8, or it must be 0. So here you need to take 2 electrons to make the level up to 8, right? So what will happen is that if we take 2 electrons like this, then the level will be completed. And if we take 2 electrons like this, the level will be completed. So therefore, there will be a bond between these pairs, right? One here and the second one here. So which means here 2 electron pairs are shared. 2 electron pairs are shared. So therefore, the molecule will be written like this. And if they ask, so these are the oxygen atoms, huh? Not the nuclear. So if they ask in the exam for you to like, let's say, to mention the remaining electrons as well, right? To mention the remaining electrons as well, then you need to mention the remaining electrons. So the remaining electrons means these ones, the unpaired ones, or unbonded. The correct term is unbonded ones, right? So here you are having 4 electrons with arranged in a pair manner, right? So there must be 4 electrons mentioned like this. Okay. So if we count the number of electrons, if we count the number of electrons per each atom, 1, 2, 3, 4, 5, and 6. So those 6 were the initial valence electrons. 1, 2, 3, 4, 5, and 6. Here also 1, 2, 3, 4, 5, and 6. But if we calculate, if we count the total number of electrons here, 1, 2, 3, 4, 5, 6, 7, and 8. The reason it is being shared like this, right? 1, 2, 3, 4, 5, 6, 7, and 8. And for this guy, 1, 2, 3, 4, 5, 6, 7, and 8. You can count it by using this diagram, right? 1, 2, 3, 4, 5, 6, the initial ones. Since these two are also shared here, it makes 8. Same thing, right? So this type of a diagram or the bond, this is known as the double covalent bond or covalent double bond, right? Covalent double bond. And the next example is for the covalent triple bond. So I'll take nitrogen molecule. So nitrogen having 7 electrons. So therefore, uh, the configuration would be 2, comma 5, right? 2, comma 5. So the number of required electrons is going to be 3 in order to make the level 8. So let's draw the setup here, right? So the first level, you are having 2 electrons. So the inner shell, right? So that is the inner shell. Inner shell won't be involving in this covalent bond making thing, right? And then you will be having the outer shell, which is having 5 electrons, right? 5 electrons. So I'm going to draw them like this. So 1 and 2, 3, 4, 5. I'm going to draw it like this. And the next molecule, next atom, So the inner shell like this. So those electrons are not going to be involved, right? And the next level, again, you are having 5 electrons, 1, 2, 3, 4, and 5, right? Like this. So therefore, what will happen? The bonding will occur between first this pair, then these two can be having a connection, and these two can be also shared, right? The reason is like the requirement is just 3 electrons, right? Per any atom, the requirement is just 3 electrons. So if we consider this atom, it requires another 3 electrons. So it will be 1, 2, and 3. For this atom, requirement is again 3, 1, 2, 3, right? So if we draw the bond structures here, so it will be nitrogen having 3 bonds like this, and the remaining electrons. So we are not going into the inner shells. We are only considering about the valence shell. Valence shell is the outer shell. shell. So therefore, there are only 2 electrons remaining in each atom. So you can draw like this, right? So here you can see 3 electron pairs are shared. So therefore, this is going to be named as a triple bond, right? Covalent triple bond, right? So remember in your exams, these sort of simple ones won't be given, right? There will be like several molecules, not the complex ones, but some molecules will be given there, right? So these are the steps, right? Uh, you can go through them later on, so I'm not going to give you any more time. Just you can use the YouTube video and go through it, okay? Right. Then let's say something like this, right? I need to draw the covalent, the bond structure for, let's say, ammonia, NH3, right? So use the steps. The first step is to identify the atoms that you are dealing with, right? So here you are having nitrogen atom and the main one, 3 hydrogen atoms. So I'm not going to write the 3 hydrogen atoms. If you need, you can write them. Okay. Okay, I'll write it. So there are 3 hydrogen atoms. So nitrogen having the configuration 7. So the electron configuration is going to be 2, 5. And hydrogen, each hydrogen atom having just 1 electron. So therefore it will be 1, 1, and 1. Right? Now, when it comes to these sort of molecules, the main thing is that you need to identify the center atom, right? Identify the center atom. Center atom means, so in the previous cases, you just had 2 atoms. So therefore, it will be like this sort of a structure. But when it comes to these molecules where you have more than 2 atoms, right? You are having more than 2 atoms, then there will be a specific atom which acts as the centered one, right? So that is known as the center atom. So in normal cases, the center atom will be the atom which is written in a least number, right? So in this case, you can see nitrogen is the least number. So therefore, nitrogen having the least number. So nitrogen will be the center atom, right? So for your level, you can guess it like that, okay? But when it comes to A levels, we will be discussing about different methods to identify the center atom, right? But for you guys, just remember the least written atom will be the center atom. But there can be some exceptions where we need to use a different method, right? So here the nitrogen will be the center atom. So nitrogen will be the center atom. So for the moment, just remember that. And now see the requirement here. So the second level must be 8, which means here the requirement is 3 electrons. And here the requirement is just 1 electron in order to make the level 2. So for the next hydrogen atom, same. And here also same, right? So Therefore, now we have configured the number of requirement for the electrons, right? The requirement for the electrons. So now we can think something, right? So we guess the center atom. So uh, the first step will be write the electron configurations. The second step, get the electron requirement. Third one, so this is the most important one, identify the center atom. Identify the center atom. Then finally, you need to configure the bonding nature, right? So here the center atom would be nitrogen. Okay, I'll draw nitrogen nucleus like this, right? And remember, when you are drawing the covalent bond structures, so read the question properly, whether they are asking you to draw the whole structure, including the inner shell, or just they are asking to draw the outer shells only, right? So remember that part. Otherwise, there's no need of wasting time drawing the inner shells. Most of the cases, we only focus on the valence shell, which is the outer shell, right? So in this case also, I'm going to draw only the outer shell. The reason is like if we draw the inner shells, like then the diagram will get messier, right? But remember in the exam, so please go through the question properly, whether they are asking you to draw only the inner shell, the valence shell, or the both inner shells and the outer shells, right? So here I'm going to deal with only the outer shell here, right? So the outer shell is like this. So here you can see in the outer shell, just 5 electrons are there, right? So in the previous case, we drew those 5 electrons. So I'll use a different color. 1, 2, 3, 4, and 5. So this is the valence shell of nitrogen. Now the hydrogen. So hydrogen atom, valence shell, it is just a 1 electron shell. So therefore you are having just 1 electron, but the requirement is just another electron to make it complete. So hydrogen will be having like this, right? So here also another hydrogen atom. And here also you can use a different way of drawing this stuff, right? Like this, right? So I'll draw with the overlapping situation, right? Otherwise you will be confused, right? So for the hydrogen, you can draw like this. Now wait. This is one, and this is another hydrogen atom, and this is another hydrogen atom. So if you count the numbers for the hydrogen atoms, 1 and 2. So now the level is completed. 1 and 2. Level is completed. 1 and 2. The level is completed. And for nitrogen, so the requirement is 3 electrons, another 3 electrons. So first you had 1, 2, 3, 4, 5, 6, 7, 8. Right? So now the levels are completed. So if we draw the other method of displaying these molecule, so here a single bond. Here another single bond. And here also another single bond. So single bonds means we are dealing with just a single line. So this nitrogen and hydrogen single, 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 and there's a remaining pair of electrons on nitrogen like this, right? So this is the method of developing the covalent bond structure, right? This is the method of developing the covalent bond structure. So if you are to get the full marks, you need to master this method, right? So there were like several important key points like deciding the center atom likewise, right? So quickly write down this, right? Try to do it by yourself and then try this molecule. So this will be our last molecule, carbon dioxide. Give it a try, right? I'll give you a few more minutes. Once after you have finished, then give me a thumbs up. Then I will discuss the perfect method of getting the carbon dioxide structure. Okay. I'll give you a few minutes, like, so now it's 8:51. I will give you like 4 or 5 minutes, right? 8:55. So in classes, we discuss these things. So these are some simple stuff, right? Okay, finish. Shall I discuss the structure? Right. So here we can see carbon and two oxygen atoms are there, right? So carbon is having just 6 electrons. So the configuration will be 2, 4. Oxygen having 8 electrons, so it will be 2, 6. And the other oxygen atom also 2, 6. Now you need to find out which is going to be the center atom. So here you can see carbon dioxide molecule. So carbon is written a least number. So therefore carbon is going to be the center atom, right? So we are dealing with the valence shell. Now write down the requirement. So here, in order to complete this level, it requires 4 electrons to make it 8. And here it requires just 2. Here it requires just 2, right? So the valence shell, carbon valence shell, you are having 4 electrons. 1, 2, 3, 4. So actually, where's the other 2 electrons? So they are in the inner level, right? So we are not dealing with the inner level. And there are 2 oxygen atoms. So it will be, so carbon is the center atom, oxygen will be the outer atoms, right? So oxygen will be like this. And these are the valence shells. So in oxygen, each oxygen atom, you are having 6 electrons, right? So I'll draw it like this. 1, 2, 3 and 4, 5 and 6. In same manner, 1 and 2, 3, 4, 5 and 6. Now the bonding. So these two will be bonded. Now count the number. 1, 2, 3, 4, 5, 6, 7 and 8. Still for carbon, it's not completed. So therefore, we need to make another bond. So these two. Again, count the number for the outer oxygen. 1, 2, 3, 4, 5, 6, 7 and 8. So for the oxygen, the number 8 is completed now. And now count for the carbon. 1, 2, 3, 4, 5, 6, 7, and 8. So for carbon also, the number 8 is being completed. So that specific number that is known as, so normally 8 is known as oct, right? So this actually this is mentioned as a rule. So each and every atom, most of the atoms, right? Not all the atoms. There are some specific ones like sulfur. They can have more than 8 electrons in their level. It is because like once you are adding more and more energy levels, the amount of electrons which can be occupied, it will be increased. So therefore, uh, so here you can see the number 8 is completed. And here also the required amount completed. And here also the required amount completed. So which means we can say all the atoms follow the octet rule, right? Octet rule, which means here the final shell must be having 8 electrons, right? So here we can see 2 electron pairs are shared. So therefore, this one is going to be a double bond, right? 2 electron pairs are shared. And here also it is going to be a double bond. So the final structure can be written as carbon, a double bond with oxygen, another double bond with the next oxygen atom, and the remaining electrons for oxygen like this, for oxygen like this. And for the carbon, you don't have any remaining unbonded electrons, right? So this is the final structure, right? And some special situations, you can try to draw SO2, SO3, like those molecules, right? So once you draw them, then you can clearly see whether these atoms are following the octet rule or not, right? So for example, yeah, I'll quickly draw these two. So sulfur dioxide, sulfur is having 16 electrons, right? So it will be 286. Sulfur 16 electrons, so therefore it will be 286. And oxygen 8 electrons, so it is going to be 26. Right? So if we draw the SO2 molecule, sulfur will be at the center. Right? I'm drawing the final structure. So for you guys, for homework, you can follow these methods and try to deduce the final structure, right? So SO2, there are only two oxygen atoms like this, right? So these two oxygen atoms will be bounded like this, having two electrons remaining. And for sulfur, the final valence shell must be having 6 electrons, right? So here 1, 2, 3, 4, 5, and 6, right? So this is going to be the final structure. You can follow the typical method and you can get this structure, right? So මම මේක කරේ මට පොඩ practice එක තියෙන හින්දා, right? So therefore you need to follow the method, the exact method, and try to get the structure, right? And the structure for SO3 sulfur trioxide, it is going to be something like this. It is going to be something like this, right? Now we'll see whether the octet rule is being completed or not. So for this thing, if we count the number for oxygen, octet rule is completed, right? You can count it. And here, octet rule is completed. But if we consider about this sulfur atom, the center sulfur atom, if we count the number 1, 2, 3, 4, 5, 6, so that is the valence number, right? 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. So if we count the whole number, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here you have 10 electrons. Here you have 8 electrons. Here you have 8 electrons, which means this sulfur atom does not follow the octet rule. Right? It does not follow the octet rule. So I'll make it red in color like this. And for the next structure, so if we count the number, this one, 8, this one, 8, and this one also 8. And this sulfur atom, so if we count the number here, 1, 2, 3, 4, 5, 6, that is the valence value, right? 7, 8, 9, 10, 11, and 12, right? So see the difference. So this guy is packing 12 electrons around him. So therefore, again, this atom, and this atom follows the octet rule, but this guy does not, right? So remember those structures and these specific situations where the octet rule is not fulfilled, right? You can draw the structures and see how the electrons are being packed, right? And and the final part here, this is actually an exam hint, right? So before drawing these structures, right? So someone might have a trouble in developing these structures. So I will give you some sort of a shortcut method, right? Some sort of a shortcut method. So you can use this method to first get this sort of a structure, then you can draw these electron distribution structures, right? So the shortcut method is this thing. So here you will be having the center atom, right? So that is going to be the center atom. And remember, if there are oxygen atoms attached at the adjacent point, adjacent means so at the end of the molecule, something like this. See, in this case, both oxygen atoms are at the end of the molecule, right? All the oxygen atoms are at the end of the molecule. So therefore, they are definitely going to be attached with double bonds. So remember that specific point. If you are dealing with oxygen atoms at the end, then it will be having a double bond like this. And another point, if the oxygen atom is at the middle of a molecule, then it will be like this. The reason is oxygen needs another two electrons. So that requirement of two electrons will be 1, 2 like this. This is for the valence, 1, 2 like this, or it can be 1, 2 like this. So which means oxygen, right? If we consider oxygen, it will have a double bond if it is at the end like this, and it will be having two single bonds if it is in a middle position, right? And remember, hydrogen will be definitely having a single bond. The reason is the requirement is just a just an electron, right? Just an electron. So here you are having the center atom, and most of the cases, the halogen molecules, right? Hydrogen or halogen. Halogen means chlorine, fluorine, bromine, likewise, right? So these molecules, these atoms will also having just a single bond in most of the cases, right? If it is at the end of a molecule, if it is at the end of a molecule, definitely they are going to have just a single bond. And if you are dealing with carbon, there can be like several types of bonds, right? It can either have bonds like this, or can have a triple bond as well, right? Can have a triple bond as well. But here remember, maximum must be 4, right? Maximum of 4 bonds must be there. And when it comes to nitrogen, it can either have like 1 bond or triple bond as well, right? For nitrogen, it can be having just 1, or it can be having 3 bonds if it is at the end like this, right? So remember these points and remember this structure. Depending on these structures, then you can easily get the molecule. For example, let's say something like this. I need to draw the structure of carbon dioxide, right? We previously drew that. Let's say carbon dioxide. So first of all, the center atom. So center atom is going to be carbon. And there are 2 oxygen atoms. So 2 oxygen atoms would be joined like this. So oxygen at, at, at the end of a molecule won't be having double bonds, won't be having single bonds like this. So definitely it is going to be double bonds. Now you can complete the number of electrons by just writing the electron configuration, right? So carbon, it is going to be 2, 4. So all the 4 electrons are being now involved here, right? Are being used here. 1, 2, 3, 4. So for carbon, there's nothing to consider. But for oxygen, it is 2, 6. So 6 electrons. So already 1 and 2 are being used. So therefore, the remaining number, you need to complete it until you complete the valence shell. So valence shell must be having 6. 1, 2, 3, 4, 5, and 6. But the requirement is another 2. 1, 2, 3, 4, 5, 6, 7, and 8. Right? Easy structures. And let's say another simple structure, let's say water molecule. So the center atom is going to be oxygen. Center atom is oxygen. And here you have hydrogen atoms as well. So definitely hydrogen going to be like this. So now you need to complete the remaining ones. So for hydrogen, it is just 1. For oxygen, it is going to be 2, 6. So there must be another remaining, the valence shell must be completed, right? So valence 1, 2, right? 1, 2, 3, 4, 5, and 6. Likewise, you can first in a sketch paper, right? In a like the extra paper, right? You can draw the structure, and afterwards you can deduce these structures in order to get the complete marks, right? So we'll quickly note down this. Okay, then the most important part, next one, how to write down the ionic bonding thing. So here we'll discuss about the ionic bond, and finally we'll conclude the session by discussing about the properties of them, right? Okay, so next one, the demonstration of ionic bonding. So as the term refers, we are dealing with ions, right? We are dealing with ions. So ions means you're having the positive ones and the negative ones. So the attraction here, the strong attraction. So that is the ionic bonding, right? So this is the strong electrostatic attraction force. Strong electrostatic attraction force, right? So for example, let's say we need to show the sodium chloride ionic bonding part, right? So first of all, remember in normal cases, right? If a formula is given like this, so the first part represents the positive ion and the second part represents the negative ion, right? So here we can differentiate this thing or break this thing from here. So this will be representing the positive one. This will be representing the negative one. Same for another example, let's say KCl. So this part will be the positive one. This is going to be the negative one, right? So here we are having the sodium ion and Cl minus ion. So sodium initially having 11 electrons, since it is making this positive one, which means one electron has been removed, right? One electron has been removed. So therefore it will be 2, 8. And this guy, Cl minus, it is going to be 2, 8, 8, right? So the thing happening here is that the removed electron from sodium, right? The removed electron electron from sodium, it will be grabbed by Cl minus, right? It will be grabbed by Cl minus. So here we can use the inner shells as well, but remember, for the attraction purposes or for the bonding purposes, we won't be using the inner shells. Definitely in all the cases, we will be using the valence shell, right? So if we draw the sodium, so the inner shell, it consists two electrons like this. And the second shell, you're having 8 electrons now. 1, 2, 3, 4, 5, 6, 7, and 8. So there was a third level, but that electron has been removed and that one is grabbed by Cl minus. So here, sodium plus 1, right? Sodium plus 1. And when it comes to Cl minus, so the first level, 2 electrons. Second level, 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And there's a third level as well, right? There's a third level as well. So the third level, previously you had 7 electrons. 1, 2, 3, 4, 5, 6, 7. And the next electron, right? The remaining 1 electron, it was grabbed from sodium. So therefore, I'll use a different color like this. So here, this is the negative ion. So this is the representation of sodium chloride, right? This is the representation of the ionic bond of sodium chloride. And yeah, we'll discuss about the structures later on. So another example, let's say something like this, magnesium chloride. Magnesium chloride. So same theory applies. The first segment gives us the positive ion. The second one gives us the negative ion. So the positive ion is magnesium 2 plus and the negative ion. So here you can see there are two chloride atoms. So you will be having Cl minus 1 and 2 atoms, ions separately, right? So magnesium configuration 12 had 12 electrons and this guy had 17 electrons. So 2 electrons are being removed. That's why you are getting this plus 2. 1 electron being grabbed. That's why you are getting minus 1 there. So 2 electrons are being removed. So the configuration will be 2, 8. And this guy will be having 2, 8, 8. 2, 8, 8. Now we need to draw the diagram. So magnesium, I'm not going to draw the complete diagram, right? So magnesium will be making the plus 2 ion and Cl, here you are having 2 chloride atoms. So here this is going to be Cl minus 1 and they are going to be another Cl minus 1 acid, right? So you need to complete the diagram. So please go through the textbooks. All the diagrams are mentioned there. Okay, right. Then for the metallic bonding, there's no specific way of mentioning the metallic bonding structures. Just you need to remember the previously mentioned electron pool structure, right? So there will be attractions between these things. So if in the exam they ask you to define these bonding structures, so here for the covalent bonding, you can say the attraction force between the shared electrons. Attraction force between the shared electrons and the nuclei. Attraction force between the shared electrons and the nuclei are known as the covalent bond. So you need to mention this shared term, otherwise you won't be getting marks. And for the ionic bonding, you can say strong electrostatic attraction forces between a positive ion and a negative ion. Strong electrostatic attraction force, strong electrostatic attraction force between a positive ion and a negative ion is the ionic bonding. And for the metallic bonding, you can say the attraction between the delocalized electron and the positive nuclei. Attraction between the delocalized electrons and the positive nuclei are known as the metallic bonding, right? So those are the three definitions. Memorize them and write it accordingly. You can't lose those terms, and therefore you will lose marks. Otherwise, like if you don't write them properly, then you will lose marks. Okay. Then the most important thing that we need to discuss. So we discussed about how to represent these bonding structures and all the stuff. Next, we need to discuss about their properties. About their properties. So for this thing also, I recommend you to to prepare a table actually, right? To prepare a table here. Then you can clearly separate, or you can clearly compare these properties. So here you are having the covalent bonding, covalent bonds, ionic and metallic. Right. So the first one, covalent bonding. So here there's a term, or you guys have learned something called a giant covalent structure, right? So here we are dealing with a giant covalent structure or lattice. So lattice is a structure where you have a certain pattern, a rigid certain pattern, right? Then for the ionic bonding, we are also having giant ionic lattice. For the metallic bonding, it is just the electron pole structure, right? It is just the electron pole structure. And when it comes to giant covalent lattices, uh, we discuss about, like here we are discussing about three giant covalent lattice structures, which are the diamond, graphite, and that C60 fullerene structure. So try to remember. So here I am preparing just a short note. So try to remember. So when it comes to diamond, all the carbon atoms are having three bonds, right? So if this is to be a carbon atom, then you have another three carbon atoms, not actually three, four carbon atoms attached to each one. So if we consider this one, another four bonds, four bonds like this. So this is a 3D structure, right? A giant 3D structure. But when it comes to graphite, you are having only three bonds, total of three bonds. So those three bonds will be like this, right? So it will be something like a planar structure. A planar structure, right? And fullerene, it is something like a sphere, right? So please go through them and memorize or refresh your memory about these structures, right? And there were some specific cases when it comes to diamond and graphite, right? So you need to compare them about their structures, about the structures, and also about the electrical conductivity, right? So those are the main points that they consider, and also about the melting point and boiling point thing. So here we only apply the melting point here, right? How, like, depending on the structure, how these physical factors change, and also some main uses about of them. And when it comes to ionic lattice structures, the common example is sodium chloride. So here we are having sodium ions and uh, chloride atoms. So remember, each atom is surrounded by six opposite atoms. Opposite means like the other type of atoms, right? So if we consider, let's say, sodium plus atom here, then six more chloride atoms will be surrounding it. So here Cl minus, and here Cl minus, Cl minus, Cl minus. So here we have drawn only four, and the fifth and the sixth will be like this: Cl minus, Cl minus, right? So afterwards, again, this Cl minus will be connected to another sodium. So here just one sodium, sodium, sodium plus, sodium plus, sodium plus. Likewise, it will change, right? So finally, you will be getting that cubic structure. So go through them and memorize those structures, right? And the next important part is so here also we will be discussing about electrical conductivity. The electrical conductivity. So when it comes to these ionic bonding structures, there's a special case, right? The special case is that if if the compound having ionic bonding, if the compound having ionic bonds, number one, if it is a solid, what about the electrical conductivity? If it is a liquid, what about the electrical conductivity? If it is an aqueous solution, what about the electrical conductivity? Right? So these are the commonly asked questions, commonly tested questions here, right? So if it is a solid, so remember, if electricity to be conducted, right? Electricity to be conducted, then you need to have either delocalized electrons. You need to have either delocalized electrons, or you need to have movable ions. Movable ions, which means the positive or negative ions, right? Movable ions. That is the most important thing. Not just ions, you need to have movable ions. Okay, just not the ions. You need to have the movable ones. So you need to, like, they must be like, they must be free to move. But in this case, what has happened? So they are attached to another atom, another ion. So which makes it is some sort of a rigid structure, right? It is attached to another thing. So therefore, these ions cannot be moved. So which means, depending on that uh, theory, we can say if it is a solid, then electricity won't be conducted, right? Electricity won't be conducted. And so I'm going to heat the solid until it changes itself into liquid. So now we are having sodium plus liquid ions, and also Cl minus liquid ions, right? So actually what will happen? So when you are changing from solid to a liquid, right? So these bonds, right? These bonds will be broken. I am providing energy in order to break these attractions, in order to break these bonds. So once these bonds are broken, what will happen? These ions can freely move, right? They are just floating here and there. So therefore they can freely move. So here, what will happen is that if it is liquid, the electricity can be passed through it, right? The electricity can be passed. So I'll highlight the liquid phase will conduct electricity. The reason is you are having movable ions. And if I let's say I'm taking the pure solid and I am dissolving it in water. Dissolving in water, right? Dissolving in water. So now also the bonds are broken. Now I'm getting sodium aqueous and Cl minus aqueous. So here again also the bonds are broken, right? Bonds are broken. You are having freely moving ions. You are having freely moving ions. So therefore, what will happen in this situation also, you can conduct electricity. So remember this part and also the explanation, right? This is actually an important part, the explanation as well, right? So there were few questions given from this segment, right? So remember the explanation as well. So remember, not all the ionic compounds will conduct electricity. If it is in the solid phase, definitely it won't, right? Definitely it won't conduct electricity. But once you are turning that, once you are converting that ionic compound into its liquid phase, or you are dissolving it in water, then you will get the electrical conductive ability, right? Okay. Then the most important property about metallic bonding is that the physical properties like melting point, boiling point, and their malleability and yeah, ductility structure. So please go through them. Those are some important points and actually easy points, right? And there was a question given like previous years. There was a question like they were asking like they gave a table mentioning actual data points, right? Actual data points like having higher melting points and mentioning about the electric conductivity as well, right? And the bonding patterns were given using different letters like X, Y, Z, like those things. So they were asking what are the bonding patterns mentioned as X, Y, Z, right? So you need to analyze the data points and you need to get an idea whether like you are experiencing a higher melting point rather than this, or experiencing that what do you call that electrical conductivity, those sort of things, right? So please revise those papers once again, right? Please go through those papers, those questions papers as well, and if possible just go through the past paper that categorized question booklets as well, right? So I will again upload them into the uh, community, WhatsApp community, and yeah. So no need of printing, no need of getting the hard copy since we are at the like the last few minutes, few moments. So there's no point of printing. Just you can refer the PDF copy and I will upload the marking schemes as well, right? So just read out the question, try to get the answer. No need of even writing the answer, right? Since we are having less amount of time. So therefore, just read the question, try to build up your answer in your head. Okay. So use these methods for the other subjects as well, right? If just imagine you are just let's say mathematics or මොකක් හරි ගණක් බලනවා කියලා. So no need of calculating, right? No need of calculating. Just try to build up your method in your head. All right. So I need to go for this step. Then finally I can get this answer. Likewise, try to build up, try to like improve your imagination, right? So that imagination part, like building up those flow charts or the steps will be added in calculation part once, yeah, we will be discussing that chemical calculation part on day after tomorrow. Yeah. So you will be needing that imaginary uh, parts. You need to improve them, right? So as I mentioned, so no need of writing the answers once again. Just go through the question, read it properly, and try to memorize your answer. Try to build your answer. So this will be something like this, right? Since we are having less time, and also for the record, like we have completed more than 40 papers for each subject, right? So please go through the papers once again and go through the notes and also the categorized questions as well, right? So yeah, and here let me check what we have to discuss furthermore. Yeah, so please refer the textbooks, right? Please refer the textbooks, and also remember that the note that I am preparing in this class is not the actual in detail note, right? So this thing is just a reminding thing, right? We are dealing just a we are using just to remind these stuff, right? So follow the textbook and also use the theory note that we have discussed in your classes, right? So yeah, we discussed all the stuff, the important stuff that will be tested in the exam, right? And for the metallic bonding, just pay attention to that alloys thing, right? And also, all right, so yeah, there's a small part that I need to discuss. I can discuss that in the chemical calculations as well, but no, I'll give it here, right? Since we have time. So here, when it comes to ionic bonding, and also remember this thing will be uh, pretty much important in chemical calculations as well, right? So you need to know how to write a chemical formula, right? Chemical formula for a given compound. The reason is like most of the cases we won't be using the exact word term for the chemical formula, right? Uh, in most of the cases, in even practical classes, in laboratory classes, you will be having just the formula, then you need to deduce what is this formula, right? So in order to get the ionic formula, right? So this thing will be mainly implemented in writing the ionic formula. So uh, you need to know about the valencies. So valencies means like the number of electrons it can grab or the number of electrons it can remove, right? So most of the time, the valencies will be just 1 and 2, or maximum of, there are some situations where you have maximum of 5, 6, 7, right? Uh, so if let's say something like this, um, the way of writing the uh, uh, chemical formula is uh, you are having the positive ion, you are having the negative ion, and you are going to exchange the valencies like this, right? Let's say the valency of this thing is X, valency of this thing is Y, and here it will be Y into X, right? For example, let's say something like this, right? You are having, let's say, sodium carbonate, right? Sodium carbonate. So there are some formulas that you need to remember actually, right? So sodium means it is just Na plus, right? If you are having this term at the end, ion, it makes the positive ion. Carbonate, it will be CO3 2 minus. And also remember, in most of the cases, the valencies will be directly equal to the charge value, right? So here the valency is 1. We are not going to write the ion there, right? Instead of the ion, we are just writing the number, right? If it is positive 1, the valency will be 1. If it is negative 2, the valency will be 2. So afterwards, we are going to just exchange the numbers like this, right? Just exchange the number. But so that is the simplest way of explaining that. But there's a deep theory meaning behind it, behind this exchanging pattern, right? So somehow we need to make the neutral compound. So therefore, you will be needing two positive ions. So that is the main theory behind it. But no need of knowing those stuff. Try to use the shortcut method and try to like try to have more and more time, and then you can revise the paper once again, the answers that you have written. So always remember, you need to go for a second round of analyzing the answers, right? At least there must be a second round of analyzing. uh, the reason is like in the exam you are in deep tension and like those stuff, ne? So even some simple calculations can be wrong, right? So therefore like for the 2 hour paper or something like that, so try to finish it by at least 1:45, right? 1 hour and 45 minutes, and then use those remaining 15 minutes to recheck the answers once again. Recheck means like you are not checking that you have written the answer or not something like that, right? ආන්සර් එක ලියලා තියෙනවද නැද්ද කියලා හිස්තැන් ටික බලාගෙන යනවා නෙමෙයි. So you need to do the calculations once again, right? Do the calculations once again and recheck your answer, right? The units and all the stuff, right? So here it will be 2 and 1. So therefore, the chemical formula, it is going to be Na2CO3, right? So this is the normal method of writing. And remember these things. So normally, most of the positive ones will be, yeah, sodium plus, potassium plus, and calcium will be making calcium 2 plus, magnesium 2 plus, and aluminium, it is going to be aluminium 3 plus, like those ones. And for the negative ones, for your syllabus, try to remember them, right? So hydrogen can make this one, hydride, but it is not given in your textbook. OH minus hydroxide, I'll write the name as well, right? Hydroxide, and this is hydride, hydride. And the most common one, oxide, okay, oxide. Then you have sulfate ions, CO3 2 minus carbonate, and the other one, so this is going to be chloride, bromide, likewise, right? So here you can see there's a special situation here. So most of the negative ones, you are having this IDE suffix there, right? IDE suffix. See, hydride, oxide, right? Hydroxide, oxide, chloride, bromide. But these are some special cases. Sulfate, carbonate, right? And even phosphates, PO4 3 minus, phosphate. So this guy is having the valency of 3, right? See the difference. And let's say I need to write the formula for calcium phosphate. So first, calcium, Ca2 minus, plus 2, sorry, plus 2. Phosphate, it is PO4 3 minus. So the valencies are going to be 2 and 3. So you need to exchange them. So here it will be calcium, and it will be 3 against 2. So calcium, there must be 3 atoms. And for phosphate, so the whole phosphate must be twice, right? The whole phosphate must be twice. So therefore, phosphate within brackets 2, right? Within brackets 2. Or you can write this same formula, right? This is something extra, right? This same formula can be written as calcium 3 P2O8. What have I done is that I have multiplied this one by 2, right? The whole bracket thing is being multiplied, right? The whole bracket thing is being multiplied. So remember, both are correct, okay? Both are correct. And let's say another one, ammonium sulfate. So ammonium is NH4 plus. Remember that, right? Ammonia is NH3. Ammonium, so ium, IUM. So it represents the positive ion. So it is going to be NH4 plus. Sulfate, SO4, 2 minus. So the valence is 1 and 2. Exchange them. So here it will be 2 and here it will be 1. So therefore, NH4 twice SO4. NH4 twice SO4, right? So there are so many examples and exercises given in your textbook as well, right? So please try to master them. The reason is like these are simple stuff, right? So without mastering these stuff, you won't be getting, like, it's really hard to get a good mark, good grade for your final exams, right? So go through them, master them, and yeah. So for today's session, I will be yeah, ending the chemistry session now, and on next day, most probably on 22nd, uh, yeah, most probably on 22nd, we'll discuss about the chemical calculation part and the electrolysis. So which means, like, on that day, we will be finishing the first unit, right? Then we are having 3 more days. We'll try to finish those physical chemistry units and the organic chemistry one and the inorganic chemistry one, right? So yeah. So these are the basic stuff, and next day I will be focusing more on the calculation. So please go through your notes and be prepared. Yeah, be prepared, and yeah. So that's all. And if you're having any sort of questions related to this stuff or any sort of questions, so just drop me a personal WhatsApp message, right? You know the number, personal WhatsApp message, and I will be available for you to answer them, right? So yeah, so that's all for today. And if you're having any trouble, just drop me a message. And yeah, thank you for joining. Okay, and have a nice day. And we will be starting the physics session at 11 a.m. So today in the physics session, we will be discussing about momentum calculations. Like, there were so many questions related to momentum calculations, and most probably we will be starting electricity unit as well, right? So we'll see, depending on the time, we'll see what will happen. Okay, so thank you for joining, and we'll start the physics session at 11 a.m. As usual. Okay, so thank you for joining, and hope to see you guys at 11 a.m.